Okay, what I have so far is that I know I want to include a velocity parameter in my renderer when I'm rendering rectangles, and I want to use that velocity parameter to modify the anti-aliasing. When something is standing still, I want to render that thing exactly where the user placed it, with no snapping or modifying of the rectangles that they pass down, and only with anti-aliasing for the partially covered pixels. And then when something is moving, I want to use the velocity parameter to stretch the shape a little bit in the direction of velocity. This avoids certain artifacts that I've been pointing out in a few of my previous videos that come with slow moving shapes in this sort of inchworm effect problem I was noticing. So far, I've built a test for this idea, but it only works along the x-axis. So the problem I have now is to solve this problem again with 2 dimensions, and then on top of that, combine in all of the features that I want in the Tool 2D graphic system. So that means I need to make this work with rounded corners, outlines, gradients, and textures. That's a big, tricky ball of things to combine, so today what I'm doing is going to have a Blackboard session to sort out a bunch of the different ideas that I've got relating to different pieces of this problem and try to map out a strategy of how I'm going to explore the set of ideas I've got. First, I want a picture of the problem to get myself started. In this picture, there's a rectangle with a velocity vector taking it up and to the right. The dotted version represents where the rectangle started, and then the solid version represents where the rectangle ends. The rectangle that is specified by the user is the same one as the one that is solid in this picture. So the user specifies the final location, and the velocity vector is actually sort of applied backwards to extrapolate out where the rectangle started in the beginning of the frame. The edges with the arrows on them, those are the velocity vectors, specifically the ones swept by the corners of the rectangle. Looking at this picture, a first question pops into my head. How will I determine the geometry for this shape? One option I have is to use explicit geometry. Here, I've circled the 6 points that lie on the outside edge of the combined shape. When I have 2 rectangles like this, I always have 8 points to begin with. And then no matter how I set up the rectangle and the velocity vector, at least 2 points will be contained on the inside of the combined shape. Hence, I only need to figure out how to extract and render a hexagon in order to do this explicit geometry idea. Looking at that option, there are a few more things to consider underneath it. So if I'm going to do explicit geometry, I'm going to have to compute that hexagon from the rectangle and the vector of motion as parameters. But I can ask, will I do that on the CPU or will I do that computation on the GPU? If I do want to do this on the GPU, that would mean probably setting up something like a geometry shader. My second major option is to use implicit geometry. With implicit geometry, I still need to do some actual geometry for the primitive, but the primitive geometry doesn't have to be the exact same shape as the final effect. All the primitive geometry has to do is cover all the pixels that do end up in the final shape, but it's also allowed to cover extra pixels that won't be in the final effect. Then what happens is the fragment shader figures out which pixels actually need to be filled in based on the geometry you're trying to render, and it can eliminate the extra pixels that your primitive geometry covered. If I take this route, then the easiest option for the primitive geometry would be to just close this whole swept rectangle shape inside of a simple quad. One part of how I might do the implicit geometry is with a blurring effect. This would mean we would take a final position of the rectangle and think of that as stationary and then try to blur it backwards towards its initial position. In this whole system, I'm assuming that the velocity is uniform between renders. In other words, the rectangle isn't speeding up or slowing down, or following some kind of curve to get from its initial point to its final point. That means a linear blur is appropriate and I won't need a kernel or any other more costly techniques like I would for something like a Gaussian blur. At the level of implementation, the way I think I could achieve this is to take the perspective of a single pixel in the primitive. In order to determine a value for the pixel, I can imagine a copy of the velocity vector emanating from the pixel. If I take several points along that vector and sample colors for them by testing against the final position of the rectangle, I can blend those samples together and get the blur effect that I'm looking for. There are a few things that might be issues with a solution like this one. For one thing, this means taking multiple samples for each pixel, so it has a higher computational cost than a solution that somehow would only take one sample per pixel. If the number of samples is relatively low, then this is probably all okay. And I can also probably mitigate most of the extra cost by skipping this whole multi-samples along the vector whenever I'm using a stationary rectangle, which I do think would be the common case. Of course, making those trade-offs would mean introducing a little extra complexity, but I think it would be manageable. Another issue is that this has the potential to reintroduce an aliasing problem. So if the number of samples is low enough, which we do want to try to drive it low for performance, and then the distance traveled by a rectangle is high enough, the samples will get spread out and become sparse enough that they might miss some critical details. Again, this could also be mitigated by dynamically setting the number of samples. So maybe it wouldn't just be that I skip this for stationary rectangles, but that I actually scale the number of samples to some multiple of the distance traveled. Or another fix might be to put a clamp on the velocity of the vector that I'm rendering, but that's only a good idea if I determine that the aesthetic implications of clamping the velocity vector are reasonable. So I'd have to investigate that first. But there are also some strong points in favor of this idea. First, this would be relatively easy to implement. That's great because it means I have a place to get started. Trying to determine if a big idea like this one is good can be hard enough on its own. And if the only solutions I have are also fairly complicated, then any bugs in the implementation could confound my ability to evaluate the big idea. So even if this isn't my final solution, it gives me a way to test this overall concept relatively isolated from other complicated issues. It also solves the color aspect of this problem, and I'm going to need some way to combine this anti-aliasing idea with the color gradients and texture mapping eventually. And since this idea approximates my own interpretation of how the velocity parameter should probably work, then I can at least see what this would look like if I had a very faithful recreation of that interpretation. In order to get a super faithful approximation, I would have to bump that sample count up, so that might not be the way I actually want to do it, but it can at least give me a way to test out what the colors should look like in a very faithful interpretation of what the velocity vector actually means. Another tool I might want to apply here is a sign distance function. I already use sign distance functions for the rounded rectangles in my renderer from the previous arc, but to apply them here I might have to consider adapting them somehow. But I want to consider using sign distance functions because they are the best tool I have for accomplishing rounded corners and rectangle outlines without having to make things super complicated. And these two tools are not necessarily exclusive. It could be that the best path would be to apply both the blurring ideas and the sign distance functions in conjunction, with the blur part giving multiple positions to sample, and the sign distance function producing the sample values for those sample positions. On the other hand, it might also be possible to adapt the sign distance function to the kind of hexagons that are created by sweeping rectangles along a vector. That would mean the fragment shader only needs to compute one sample for each pixel, which would be great. However, it's not immediately obvious to me how I would ever get a solution to the color part of the problem from that sort of approach. There is another problem to consider that applies to any version of the implicit geometry path. The primitive geometry encloses pixels that will actually end up untouched by the final effect. And it is possible, given the way I've set it up so far, for the number of untouched pixels to far surpass the number of touched pixels. In fact, there's no bound on how many untouched pixels I might end up with. Just consider the case of a small rectangle shooting across the screen with a high velocity. It could potentially trigger fragment shading on every single pixel on the screen, only to leave a trace on less than 1% of the pixels. And while that's probably not going to be a common case, I do want to consider whether or not the architecture I'm building thinks of that as legal or not for the user to specify. And if it is going to be legal, then I want some kind of way to mitigate the potential cost. One very easy solution would be to clamp the velocity, and I've already mentioned that idea once as an option to mitigate an aliasing problem in the blur effect. So since it's come up twice now, I definitely want to test the aesthetic implications of clamping velocity, because if it's okay for me to do that from a visual aesthetics perspective, it looks like it could solve a lot of problems. Another solution might be to use slightly explicit geometry. That would mean doing some sort of calculations like I would have done with the explicit geometry, except with a little more wiggle room for slop around the edges. While there would still be untouched pixels going through the fragment shader this way, those untouched pixels would actually be bounded relative to the number of untouched pixels, because I would not have the giant sections of corners of the rectangles that have untouched pixels, just the sort of boundaries around the edges of my swept out rectangles, those hexagons, as I was pointing out earlier, it would just be their edges that could have untouched pixels and not the entire screen. In particular, if you think about explicit geometry, doing rounded corners and outlines would be extremely difficult, so much so that I'm almost certain we won't go down that path. But the slightly explicit geometry wouldn't have that problem because we could still get the rounded corners and outlines from the fragment shader, but do the rest of the culling with the geometry. From here, my blackboarding session went on for a little while longer. I asked some questions from a few other angles and explored ideas as they came up, but everything I looked at led back to the same basic ideas that I already had here. So these are the main ideas I'm going to try to work with. Calculating blur by sampling along the vector of motion does seem like the best natural starting point, so that's where I'm going to get started, and I want to see how that looks just with plain rectangles. If that works, then I want to try to combine it with the sine distance function to get in the rounded corners and the outlines. And then somewhere along the way, I also want to test out the velocity clamping idea to see whether or not that's an option. If this collection of ideas doesn't come together into a good effect, I still have this blackboard, so I could come back and review some of the ideas I had and put together a next strategy. But for now, I want to set aside everything besides those two main ideas, the blurring idea and the sine distance function idea, with the velocity clamping sort of minor idea as well. I'm going to focus on those and get started on that next time. See you then.